Hello and welcome to the next episode of To Be Astronomer reacts to the 27 questions the Globe Defenders apparently can't answer. I believe so far we've done a quite well job. Now, this is actually the second time that I'm recording questions 13 and onwards. Because when I did it the last time, for whatever reason, it didn't record the screen, and I thought, because I showed actually a couple of things, I thought, I probably should redo the whole thing. So, without further ado, let's go ahead. I will just turn it to 125 and let's go.
What is the cause of gravity? Ooh.
Well, last time we answered question 12, and I've already gone a bit into it, right? Maybe first let's keep Flatside talking and I'll answer it then.
Yeah, so first you have to tell us what gravity is, and then you're going to tell us what is the cause of gravity. I've had many debates with like FTFE, and well, he simply can't tell me what the cause of gravity is. He just says
he does every time. Mass attracting mass. That's what he says every time.
gravity is the cause.
No.
And then you ask, okay, what caused gravity? Distance. It's like what? Or mass attracting mass, or the distance of the, or no, the best one yet, weighting.
No one's ever said weighting. I would like to have a source for that. So what Flatside is attesting to here, like specifically what he says now, are the responses that he has gotten to the question of the cause of gravity. Okay. Before I talk about his specific situation, I'd like to outline it a bit broader. So when someone asks for a cause of gravity, right, depending on what their existing information is, there are a whole suite of possible answers, 3 to be precise. The first and most basic one, and also the one that is perfectly fine for everyday understanding, is mass attracting mass, right? That's completely sufficient for your everyday understanding of gravity, is mass attracting mass. And that's at the end of the day really what it boils down to. Yeah. So mass attracting mass is a perfectly fine explanation of what is the cause of gravity. Now, if one were to ask, how does it do that? Like, what's the mass doing? I've already talked about that for question number 12. It's changing the geometry of space-time. So the 3D geometry that we are in, like the 3D space that we are in, can be changed in a way that changes the fundamental geometry of how things move and why things move. This is outlined in Einstein's general theory of relativity, right? So the first answer is mass attracting mass. That's a perfectly fine answer. The second answer is the cause of gravity is a change in space-time geometry that manifests as a force, or it causes a force, or something along those lines. Now, there is also a third answer to the question, which is on a more particle kind of physics side, a more fundamental physics kind of side. And that's, well, it has to be some sort, at least following our current understanding of physics and how forces work, there has to be some sort of carrier particle that carries the force, right? This particle would be, for the electromagnetic force, would be a photon. For the strong nuclear force, it would be a gluon, and for the weak nuclear force, it would be the Z boson or the W boson. And for gravity, there is a thing. It's called a graviton. Although this is a hypothesized thing, importantly hypothetical, we have not yet found the graviton. According to our current understanding of quantum and particle mechanics, it should be there, right? We just haven't found it yet. We can even already talk about a couple of its quantities. It has to have a mass of 0 and an electric charge of 0 and a spin of 2, interestingly enough. So this is what should exist according to the standard model, if we understand it the way that we do. Doesn't necessarily mean that there really is one. We haven't found one yet. There's most certainly a search for it. Might as well be that there isn't one. Then we would have to adapt the standard model. Maybe But in principle, I do believe that there is one, and I do believe that we probably will find it. But I could very much be wrong on that, and that's fine. So these are the three answers. The first one is mass attracting mass. The second one is change in the geometry of spacetime. And the third one is, well, at the fundamental level, some sort of particle, most likely a graviton. Now, what Flatside has said here with distance and time, he probably was referring to someone answering with what causes gravity, someone answering with the equation of the general law of gravitation, which is also a fine thing to do, right? The cause, if you will, for that are the masses. However, as should be pointed out, the gravitational force decreases with the distance squared. It's kind of like the inverse square law in that regard, right? If you're twice as far away from an object, the gravity there is going to be a quarter. So that's the important part, right? And probably someone has said to Flatside, well, if you're further away, gravity is going to be weaker. And Flatside has interpreted this as the distance causing the decrease in gravity, which is, of course, I mean, that's just not how that works, right? The mass is just further away, and thus the effect on you is smaller. It's proportional with, as you can see here, 1 over the distance squared. It's not difficult. He has also said time, or just wait. I don't know what he means there. Could probably be that he misunderstands a lot how Uranus was detected, because they essentially waited for it to pop up, well, not pop up, to fly into the region that they have calculated where it has to go, which, by the way, is a magnificent piece of evidence for Newton's law of gravity and our understanding of orbital mechanics, which this single thing is better than what any flat earther as of yet has predicted, just mentioning. But yeah, so I think that's question 13 pretty thoroughly answered.
Time.
So yeah, what is the cause of gravity, people?
People's imagination.
Gravity, man. You get it?
Did gravity cause gravity? But what's gravity?
Gravity doesn't cause gravity.
It causes itself.
Yeah, okay.
What's our observed
Yeah,
phenomenon
if mass,
to come
then
up with the
mass.
hypothesis?
Right?
I love how he has a whole arena of people who just make fun of the stuff that he misunderstands, or like that they misunderstand. This is very comical to me.
Can we go through that? If mass, then mass. When they get done with everything.
So inertia, resistance of inertia attracts inertia, resistance of inertia.
So inertia is a bit of an antiquated idea that was the old answer for what is mass, right? Sometimes people ask what is mass, and the old answer that was given was it is a resistance to movement. So it is kind of a resistance to inertia. Inertia being kind of an old physical idea that if you poke something, it has inertia, and this inertia makes it move continuously, which is, of course, like today we know that if you poke something, it moves because there's nothing to stop it moving, unless, of course, there's friction present and stuff like that. So I kind of don't like inertia. You also completely don't need it in any physics reference. Like I have gone through like 5 years of studying at the university, both physics and astronomy, and we have never needed inertia, and we've only like mentioned it a couple of times. So like, oh, you could explain that, this and that with inertia. So it's really superfluous by now. My answer, by the way, for what is matter would be it's just I do apologize. Would be it's just a fundamental property of stuff, right? You can have as a fundamental of property of stuff, you can have spin, you can have charge, and you can have a mass. It's just one of the things that is fundamental or seemingly fundamental.
I mean, this is how dumb the guys are. They don't actually know that mass has the same definition of inertia.
Mass is defined as a resistance to
Number
inertia.
14. Why is there no scientific hypothesis for gravity if it's claimed to be scientific?
Now, this point I love, because it's so wrong and so on the nose wrong. How should I say it? First of all, there's currently no scientific hypothesis for gravity because we've moved on far beyond the hypothesis. We are not at the stage of an hypothesis anymore. We have long since graduated. Gravity has long since graduated to a theory. Now, I'm aware that a lot of flat earthers don't know the terminology, but the terminology is kind of stupid because science is extremely bad. Like, scientists are extremely bad at naming things. So I thought I'd briefly line out what the law mean, like what's a law, what's a theory, what's a hypothesis. I've mentioned it in the previous video, but I can mention it again. Because I have it still open, we can say that Newton's law of gravity is, of course, a law. It describes one single kind of thing, right? It doesn't say anything about the sky. It doesn't say anything about the other stuff that's usually explained within classical mechanics. It just says the force that is the gravitational force that can be measured between two masses is that. That's it. That's a law. Law is usually something small and something simple, right? So if you take a bunch of laws together and you have a kind of a background idea behind why the laws are the way they are, that's then usually a hypothesis. Now, your hypothesis makes some predictions. For example, the standard model predicts the graviton that we talked about earlier. Now, the standard model already is a theory because it has made plenty of other predictions that have all come true, but essentially, if you have a hypothesis, which is you haven't collected much data yet on the subject, or there isn't even much data on that subject, so it turns out that it's an hypothesis, and eventually you're going to measure it, you're going to do observations and stuff like that, and then you find out that is actually true. And if a whole bunch of the predictions of the hypothesis also come true, then what you do is you end up with a theory. Now, scientific theory is different from what is colloquially understood as a theory. When I talk about theory to my friends, well, I don't, because I actually kind of like the word theory in the scientific sense as being a whole body of knowledge, both from a theoretical and an observational or an experimentational side, that agrees with the underlying interpretation of what it does and how it does it. So, for example, general relativity is a theory. It is also known as Einstein's theory of general relativity. And this has so much observational and experimentational, but also theoretical knowledge and exploration behind it, and it all adds up. It all kind of makes sense. All of the predictions of Einstein's general relativity have come true to a certain amount of gravitational waves, the gravitational redshift, or the orbit of Mercury. All of that stuff could have been, has been confirmed using general relativity. That's why it's gone and kind of it's been promoted. It has graduated to a theory. And when you say here that there is no scientific hypothesis, I would ask you to go through a whole bunch of the references and the sources and all of the bibliography here, a whole bunch of which has started out as a hypothesis. So, because I think you don't ask the question, why is there no scientific hypothesis about gravity? As in the sense that are there only theories and laws and no hypothesis? I think you are going here for why is there no scientific kind of anything for gravity, in which case I will ask you to have a look at all of those and tell me why there isn't one, or what your problem is with all of these. And this is not an appeal to authority, because that's what you're going to say next, really, right? This is nothing of that is an appeal to authority. None of those are authoritarian by any means. It's just there have been so many people who have thought about all of these topics, right? And we agree on that. I'm not a gravitational physicist. I'm not good at general relativity, although I've done a course on it. So it's not like there are major disagreements with the stuff that's established. There are not barely even minor agreements with the stuff that is established. So if you go here and you say none of that's scientific, I'm afraid you're gonna have to tell me how and where and why. Also, and I know that you saw the video because you commented under it, you have seen where I quote pages from a book that's Elements of General Relativity by Piotr Kruszczyk. That's the book that we used in our lecture. And so you know that there is at least one book. So why do you say it's not scientific then? Not a difficult question. Also, by the way, let's say you mentioned that those are supposed to be difficult questions, but they're really not.
What's the phenomena?
Yeah, you first have to observe it, correct? But the thing
Mass attracting mass is observable.
is, it is claimed to be scientific, correct?
Hold on, that's real science, observing a natural phenomenon.
Yeah.
That's real science there. They don't have it.
Nope.
They have pseudoscience.
Yeah, they do.
I find it funny that flat earthers accuse us of pseudoscience when they're absolutely incapable of reproducing or anything because they don't reproduce. Because that's what flat earthers do. They just say. When MC Toon says that so nicely, flat earthers are pseudoscientists when making up stuff and deniers when judging stuff from globe earthers.
But you understand what I'm saying? Because they claim it to be science, what is the scientific hypothesis for gravity? You would have a scientific hypothesis if they...
We are so far beyond hypothesis. We are very much at a theory.
What if it was science? So yeah, it's just them forcing out.
And if you want to know what the theory of relativity is, well, I mean, you could buy a book on general relativity, but this will very much be over your head, not because you're stupid or something, but because it's really fucking hard. You would first need kind of a course on differential geometry, and before that you would need to do your like analysis and algebra stuff, because I honestly, sorry, but like that's kind of a prerequisite for not, like for being a flat earther, is not really having a tight grasp on algebra and analysis.
To show it's just pseudoscience. So Phil, I
Like
don't know how you're going
calculus
to answer this one, mate.
Like calculus and stuff, you know.
Go ahead and present to us an actual scientific hypothesis used for gravity. By the way, you can't do it because it doesn't exist.
Because we're not at an hypothesis anymore. For so long, like for borderline 100 years at this point.
Good luck. Okay, next question. 15. Why can't you validate the Earth's rotation scientifically?
You can, and it's super duper easy. So, well, there are so many ways you can do this, right? We at our university, we do it like everyone has to do that in their third or fourth, I believe it is, term with a radio telescope, where you point the radio telescope at an object, you measure its the Doppler shift, so from that you can determine the velocity that we are moving towards it or away from it, like the relative velocity if you want. And from that, you wait 12 hours, you point the telescope at the same exact object. At the one time it was precisely in the east, and at the other time it's precisely in the west. And what you see is that the relative velocity has changed, surprisingly, well, very unsurprisingly actually, by the exact amount that Earth is rotating. We do the same thing with Earth's orbital velocity, where you then wait 6 months, then you point your telescope at the same thing, and you see that there's a difference in orbital velocity, right? So, yeah, that's a thing that we do. Everyone does that. There have been over 100 people, like, well, we're talking about 100. There have been probably like close to 1,000 people just at our university who have measured Earth's rotation, and it's not difficult, right? So, and if you don't even want numbers, if you're just fine with like basic observations without like getting any of the straight numbers, well, then it's even easier. Have a look at the sun, right? There's a guy from a German flat Earth debate person, Flo Plus. I can't recommend him enough. He's if you understand German. There's a video of him. Now, of course, I didn't prepare it because even though I'm doing this for the second time, I'm still doing it kind of blind. But there are so many, like he explains how the rotation. Okay, how do I explain it? Imagine you're sitting on your office chair, right? And you are fixing a point, let's say on your computer screen, and then you turn, like you rotate on your office chair by a constant amount, like 5 degrees every second or something like that, right? And if you were to plot the position of the point every 5 seconds, distance between the point would be constant. Like the distances between the points would be constant from your field of vision, kind of, right? So, because you're rotating constantly on a flat Earth, if it was moving away due to perspective, it would actually perspectively shift. So, the further away it gets from you, the closer the points would move together, right? So that's a thing that you can measure easily. Just make a time lapse of the sun from one day. A single time lapse for the sun would show that either the sun is rotating around Earth, or either the Earth is rotating like the way that we say it does, essentially. Could also be that the Earth is fixed and the sun is rotating around it in a constant fashion. But like that's halfway there. Both of these things disagree with a flat Earth. Also, if you have noticed on my channel, the recent thing with Dream Caliber, with the pyranometer and the pyrheliometer and the solar irradiation and stuff, all of that also shows that we are rotating. As I've modeled and shown clearly, by the way, Dream Caliber still hasn't answered. He still hasn't provided me with any data. If I was a mean person, which I try not to be, especially online, I would say that he has run away because he's seen that he's lost. But yeah, so you absolutely can validate Earth's rotation, and it's so easy. It's so easy to do that. It's mind-boggling how anyone could not understand it. The sheer fact that you have counter-rotating poles can only happen if Earth is rotating. If things were like you say, with the sun moving perspectively away, it would never set. The distances between the individual points of the sun's position per unit time would vary all day long, which on the globe Earth they don't, apart from the very sunrise and sunset, because there the atmosphere is very thick and does strange stuff. But yeah, so we can validate it, and it's very easy, and it's done frequently, and you don't need any scientific equipment for that, although of course that would make it easier.
Very simple.
Because it's not fair.
Exactly.
It is extremely simple. You're just not doing it because no flat earther ever does stuff, right? You say you don't because for whatever reason.
Can't detect something that's not happening.
Uh-huh.
It's very good.
Oh yeah, and by the way, Earth rotation or Earth shape is not science.
I'd argue it's a measurement, depending on which is what your stance is on if measurements are a part of science. That there is some debate sometimes. I would argue careful measurements and catalogization is very much science, like Carlos Linnaeus did, right? For zoology. I would argue that very much is science because it can be used to contribute significantly to a scientific theory. And out of careful catalogization and measurements, even a theory or like a hypothesis can be made, or laws can be drawn from that. So but if you say it's not science, that kind of is fine. I'm okay with people saying it's just a measurement, but it's still a measurement. And you are essentially disputing this measurement by saying, nuh-uh.
So yeah, it's actually an oxymoron.
It's not. An oxymoron is if you say a vegan sausage, right? Because sausage includes the definition of it being made from meat. That's an oxymoron. That's not an oxymoron.
Okay, number 16. Why no Stella?
And I believe I have covered question 16 in the next episode. So with that, because I've already done the next episode, because I'm redoing that because it didn't record stuff. So with that, I thank you very much for watching. If you did enjoy it, I would ask you to maybe consider leaving a like, or possibly even consider subscribing. And with that, I hope you enjoyed this episode, and I will see you in the next one. Goodbye!